Good morning, everyone. Thank you for joining me today. I am Preet Pannu from Abu Dhabi. I am a grade 11 student of Abu Dhabi Indian School. Currently, I have taken computer science as an elective, and I am learning Python programming as part of the same. I have been wondering why we are being taught Python programming and what are its advantages in real life. I have done some research on my own, and today I would like to share the outcome of my research on the topic Python in machine learning. Before discussing why Python has become such a popular programming language in the field of machine learning, let's first try to understand machine learning, its definition, importance, and types. Machine learning is a subset of artificial intelligence, or commonly known as AI, that involves the development of algorithms and models that enable machines to learn from and make predictions or decisions based on that data. So, machine learning is a type of computer technology that helps computers learn from data and improve their performance on tasks without being explicitly programmed. It's like teaching computers to get better at something by showing them examples instead of giving them step by step instructions. Interesting concept, right? Now, let's try to understand the importance of machine learning. Machine learning allows organizations to analyze and extract valuable insights from large volumes of data, enabling data-driven decision-making processes. Machine learning algorithms can automate tasks that would be time-consuming or impossible for humans to perform at large scales with high efficiency and reduced costs. ML enables businesses to personalize products, services, and recommendations for individual users, enhancing customer satisfaction and engagement. Machine learning models can make accurate predictions and forecasts based on historical data, helping businesses anticipate trends, customer behavior, and market changes as well. ML can optimize resource allocation by identifying patterns and trends, leading to better inventory management, supply chain optimization, and lower energy consumption. Machine learning is revolutionizing healthcare with applications like disease diagnosis, drug discovery, and personalized treatment plans. ML algorithms are used to commonly detect and prevent cyber attacks, frauds, and other security threats by identifying anomalous patterns in the data. Machine learning powers autonomous vehicles, drones, and robots, enabling them to perceive and navigate their environments. Machine learning techniques facilitate language understanding and translation, chatbots, and voice assistants like Siri and Alexa. ML aids scientific research by analyzing complex data sets, modeling intricate phenomena, and making predictions in fields such as astronomy, physics, and genomics. ML is used in risk assessment, algorithmic trading, and fraud detection in the finance industry. ML algorithms drive recommendation engines in platforms like Netflix, Amazon, and Spotify, increasing user engagement and thus their sales. Machine learning also helps monitor and manage environmental issues by analyzing satellite data, climate models, and predicting natural disasters. Machine learning assists in creating tools and technologies that make the digital world more accessible to people with disabilities. Machine learning models can adapt and improve over time, making them valuable in dynamic and constantly evolving environments. To summarize, we can say machine learning plays a crucial role in various industries, enabling automation, optimization, and innovation, while enhancing our ability to process and leverage vast amounts of data for practical purposes. Now, let's discuss the types of machine learning. It can be broadly categorized into three main types, which are supervised learning, unsupervised learning, and then reinforced learning. In supervised learning, the algorithm is trained on a labeled dataset, where each input is associated with the correct output. The goal is to learn a mapping from inputs to outputs, allowing the model to make predictions on new, unseen data. Unsupervised learning involves training a model on an unlabeled dataset. The goal is to discover patterns, structures, or relationships within the data without any explicit guidance. Common techniques include clustering and dimensionality reduction. Reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with an environment. It receives rewards or penalties based on its actions, and the objective is to maximize cumulative rewards over time. This type of learning is commonly used in applications like game playing and robotics. Additionally, there are other specialized types of machine learning, such as semi-supervised learning, self-supervised learning, and deep learning, which is a subset of machine learning that focuses on neural networks with many layers, which we call deep neural networks. These different types of machine learning techniques are used in various applications across fields like healthcare, finance, natural language processing, and computer vision. Now, look at why Python has become such a popular programming language in the field of machine learning. Python's simple and clean syntax makes it easy for beginners to learn and understand. Its readability and indentation-based block structure makes the code more human-readable, which is crucial for collaboration and maintenance in machine learning projects. Python has a rich ecosystem of libraries and frameworks tailored for machine learning and data science, such as TensorFlow, PyTorch, scikit-learn, Keras, and many more. These libraries provide pre-implemented functions and classes for various machine learning tasks, significantly speeding up the development. Python also has a large and active community of developers and data scientists who contribute to its growth. This results in extensive documentation, tutorials, and online resources that can help you learn and troubleshoot issues in machine learning projects. Python is a general purpose language, which means that you can use it for various tasks beyond machine learning, such as web development, scripting, and scientific computing. This versatility is advantageous for building end-to-end machine learning applications. Python is compatible with various operating systems, making it easy to develop and deploy machine learning models across different platforms. Python can be seamlessly integrated with other technologies commonly used in the data science and machine learning stack, such as SQL databases, NoSQL databases, cloud platforms, and big data frameworks such as Hadoop and Spark. Python offers powerful visualization libraries like Matplotlib, Seaborn, and Plotly, which help in data exploration and model evaluation by creating informative plots and graphs. While Python is not the fastest language for certain computations, it allows you to leverage external libraries and technologies like NumPy for numerical operations to optimize performance when needed. Moreover, you can utilize GPU acceleration with libraries like TensorFlow and PyTorch for high-performance machine learning. Python and most of its machine learning libraries are open source, meaning they are free to use and have a vibrant community actively improving and extending them. Python is widely adopted in the industry, making it an excellent choice for machine learning professionals who want to work on real-world projects and collaborate with other data scientists and other engineers. To summarize, Python's combination of simplicity, extensive libraries, community support, and versatility makes it an excellent language for both beginners and experienced professionals in the field of machine learning. Since we are discussing Python, let's look at the background of how Python has evolved. Python is a high-level, versatile, and easy-to-read programming language known for its simplicity and readability. Created by Guido van Rossum and first released in 1991, Python has gained immense popularity since then due to its advantages as discussed in the last few slides. In Python, there are several key data types, control structures, functions, and libraries for handling and manipulating data. Let's look at these in more detail. There are several key data types, such as lists, NumPy arrays, and pandas data frames. Each of these data types has its own characteristics and is suitable for different data manipulation tasks. You can also convert between these data types as needed. For example, converting a list to a NumPy array or a pandas data frame, depending on the requirements of your data analysis or manipulation tasks. Control structures are an essential part of programming languages like Python, allowing you to control the flow of your program based on certain conditions or perform repetitive tasks using loops. Here are some of the most common control structures in Python. These control structures are fundamental in Python and are used extensively to create conditional logic and perform repetitive tasks in your programs. Now, let's dive into some of the most popular libraries and frameworks used in Python for machine learning. Functions in Python are blocks of reusable code that perform specific tasks. They are defined using the def keyword, followed by a function name and parentheses. You can pass arguments to functions inside the parentheses. Functions can return values using the return statement. They are essential for modularizing code and making it more organized and maintainable. Libraries, also known as modules in Python, are collections of pre-written code that extend the functionality of Python. Python has a vast standard library that includes modules for tasks like file handling, math operations, and more. You can import libraries using the import keyword. Third-party libraries not part of the standard library are also available for various purposes and can be installed using package managers like pip. Now, Python is a popular programming language for machine learning, and it has a rich ecosystem of libraries and frameworks that make it easier to develop machine learning models. Here are some of the most commonly used Python libraries for machine learning. Scikit-learn is a powerful library for classical machine learning algorithms. It provides simple and efficient tools for data analysis and modeling, including support for classification, regression, clustering, dimensionality reduction, and more. Developed by Google, TensorFlow is an open source machine learning framework for deep learning tasks. It is widely used for developing neural networks and has a high-level API called Keras for building and training models. Then developed by Facebook's AI research lab, PyTorch is another deep learning framework that is gaining popularity. It is known for its dynamic computation graph and flexibility, making it suitable for research and production. While Keras is often associated with TensorFlow, it's also available as an independent library that can run on top of other deep learning frameworks like Microsoft Cognitive Toolkit, CNTK, and Theano. It offers a user-friendly, high-level API for building neural networks. XGBoost is a highly efficient library for gradient boosting algorithms. It's widely used for structured or tabular data problems and has won numerous Kaggle competitions. Then, LightGBM is another gradient boosting library developed by Microsoft. It is known for its speed and efficiency, making it suitable for large data sets. While not a machine learning library per se, Pandas is essential for data manipulation and pre-processing. It provides data structures like data frames and tools for working with structured data. NumPy is a fundamental library for numerical computing in Python. It provides support for arrays and matrices, which are essential for many machine learning algorithms. Let's look at libraries that use data visualization. Matplotlib is a comprehensive library for creating static, animated, or interactive plots. Seaborn is built on top of Matplotlib, and it provides a higher level interface for creating attractive statistical graphics. Natural Language Toolkit and SpaceCY are commonly used for natural language processing or NLP tasks. NLTK provides a wide range of tools for text processing and analysis, while SpaceCY is known for its speed and efficiency in NLP pipelines. These libraries, along with many others in the Python ecosystem, offer a wide range of tools and capabilities to tackle various machine learning and data science tasks. The choice of library depends on your specific project requirements and preferences. Now, data preprocessing is crucial because it ensures that our data is clean, consistent, and ready for modeling. It can significantly impact the performance of our machine learning algorithms. We load our data, handle missing values, encode categorical variables, split our data, and scale the features. By following all these steps, we ensure that our data is clean and ready for modeling, ultimately improving the performance of our machine learning algorithms. Supervised learning is a key part of machine learning, where algorithms learn from labeled data to make predictions. It is used for classification and regression tasks and implemented in Python with libraries like scikit-learn, TensorFlow, and PyTorch. The process involves data pre-processing, splitting it into training or testing sets, selecting a model, training, evaluation, and hyperparameter tuning. Real-life applications of this include healthcare, finance, and e-commerce. Challenges include overfitting, data quality, and bias. Python code examples can illustrate these concepts. Supervised learning empowers us to solve various real-world problems with informed decisions. Unsupervised learning is a branch of machine learning where algorithms analyze unlabeled data to discover patterns and structures. It is used in clustering, dimensionality reduction, and anomaly detection. Python libraries such as scikit-learn facilitate its implementation. Key steps involve data preprocessing, algorithm selection, model training, and result interpretation. Real-world applications of this include customer segmentation, image compression, and network security. Challenges also include choosing the right algorithm and evaluating the results. Unsupervised learning empowers data-driven insights without any predefined labels, making it a valuable tool in various domains, facilitated by Python and its libraries. Then, evaluation and validation in Python are crucial steps in machine learning. They ensure model accuracy and reliability. Methods like train test split and cross-validation are used, and common metrics include accuracy, precision, recall, and F1 score. Python libraries like scikit-learn and visualization tools like matplotlib are valuable for these tasks. Challenges include avoiding overfitting, ensuring data quality, and addressing the bias. Overall, these processes help ensure that machine learning models perform well and are suitable for real-world applications. Then, deep learning with Python is a subfield of machine learning, focusing on neural networks with multiple layers. But what is a neural network? Well, a neural network is the method in artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. It is a type of machine learning process called deep learning that uses interconnected nodes or neurons in a layered structure that resembles the human brain. Python has powerful libraries like TensorFlow, PyTorch, and Keras for deep learning. Building deep learning models involves data preparation, defining architecture, compilation, training, evaluation, and fine-tuning. Common architectures include CNNs and RNNs used in applications like computer vision, natural language processing, and speech recognition. Challenges include the data size, computational resources, and model interpretability. Deep learning is a potent approach to solving complex problems across domains, leveraging Python's capabilities and its libraries. Deploying machine learning models in Python involves making models accessible for real-world applications. Methods include APIs, serverless computing, containers, and edge devices. Key steps include model export, setting up the deployment environment, API development, testing, monitoring, scaling, security, and documentation. Python tools like Flask, Docker, AWS Lambda, and FastAPI facilitate this development. Considerations include versioning, scalability, latency, and data privacy. The best practices involve CI/CD, model drift monitoring, and user feedback. Successful deployment bridges the gap between model development and practical use, turning research into impactful solutions. Deploying machine learning models entails addressing challenges like model drift, latency, data privacy, scalability, and versioning. To overcome these hurdles, the best practices include implementing continuous integration and deployment known as CI/CD, continuously monitoring model performance, gathering user feedback, enforcing robust security measures, providing clear documentation, employing version control, optimizing resource usage, conducting thorough testing, educating users on model limitations, and promoting collaboration among teams. These practices enhance model reliability and security while ensuring effective real-world application. Python offers a range of tools and libraries for enhancing model interpretability in machine learning. Notable options include XAI for expandable AU, SHAP for feature importance, LIME for local explanations, ELIFI for model debugging, Yellowbrick for visualization, Interpret ML for model agnostic interpretability, Tree Interpreter for tree-based models, Scikit-learn for feature importance, Matplotlib and Seaborn for custom visualizations, PDP-box for partial dependence plots, and XGBoost plotting for XGBoost models. All of these tools empower users to understand model predictions, feature contributions, and decision-making processes, facilitating more informed and transparent machine learning model usage. The future trends in Python and machine learning encompass several key areas. These include a heightened focus on reinforcement learning, AI ethics and fairness, the rise of explainable AI or XAI tools, the growth of automated machine learning called AutoML, and the emergence of quantum machine learning. Other trends include federated learning for privacy, edge AI for IoT devices, advancements in natural language processing, NLP, and AI's expanding role in healthcare and climate change solutions. Additionally, Python will continue to be instrumental in quantitative finance, AI regulation, distributed machine learning, model explainability, AI-assisted development, and machine learning education, reflecting the ever-evolving landscape of these fields. In conclusion, Python is a powerful programming language that has become the go-to choice for many machine learning practitioners. Its simplicity, extensive library support, and active community make it an ideal language for implementing machine learning algorithms. Whether you are a beginner or an experienced developer, Python provides the tools and resources needed to excel in the field of machine learning. Now, I would be happy to answer any questions that you may have. Please feel free to ask anything related to the presentation or machine learning in general. I can see that there's a question from a student. The question is, I want to be a data scientist. So which programming language should I prepare during my high school? Well, as you know, there are many programming languages used at the university or college level, such as Java, C, and Python. Since you are targeting data science, I recommend you practice and prepare for Python language as a head start for your data science major at the university level. And I think that is all with the questions. So thank you all for your attention and participation today. If you have any further questions or would like to connect, please feel free to reach out to me. Have a great day. Thank you.